reducing an arbitrary system of forces to its simplest form, the lesson number 216 from the book Mechanical Systems Calculations of the Marine Facilities. Sometimes to decide the main issues of the statics is finding all the support reactions and developing of the balance equations for the elements of the mechanical systems. We would reduce the arbitrary system of forces to its simplest form. Just please look on the example on the figure 2.16.1a. We have just force applied to the absolutely rigid mechanical body in the point A. And we have Cartesian coordinate system x, y, z, 0, x, y, z. The 0 could be the reference point. We can apply in the point B. AB is a radius vector of the force F. So we can apply in the point B is the same as a 0 point, as a reference point, origin of the coordinate system, two balanced forces equal in the magnitude to the assigned force F. One force is F1 stroke and another one force F2 strokes is shown on the figure 2.16.1b. And this system of forces gives us, first of all, the force applied in the new location. I mean, the force as F stroke parallel to the assigned force F, but applied to another one point to the beginning of the radius vector BA. And this force, and we have as well two forces remained, assigned force and F2 strokes balanced force to the force F stroke. And this cause, I mean, the couple of the forces F and F2 strokes caused the appearance of the rotating moment M be around point B or around the point 0 is not so much important. And this is M. So by this way, we transform the application of force F to any, could be arbitrary point A, to the reference point and the origin of the coordinate system 0, or it could be B, and to the rotating moment, vector rotating moment of the body by the force around the point B, which coincides with the point of the reference and the coordinate system. We have a theorem on parallel force transfer. We transfer this force F parallel to point 0, to point B, about the same. A force applied to solid body can be transferred in parallel to any point of the body by aiding wherein a pair of forces, we have pair forces, F stroke and F2 strokes, the moment of each is equal to the vector moment of the transferred force relative to transfer point. So moment caused by the couple of forces F and F2 strokes balanced with the force F stroke, product of the transfer of the force F to the point, from the point A to the point B. Reducing arbitrary system of forces. We have arbitrary system of forces in the Cartesian coordinate system 0, x, y, z. We have forces F1, F2, F3, etc., Fn. And we can reduce this arbitrary system of forces to a force and a pair of forces. Pair of forces, or couple of forces, gives us a rotating moment around the point of the reducing of this system of forces. To do this, one needs to apply the center 0. Center 0 could be reference point of the coordinate system, or it could be any other arbitrary point taken in the body inside or maybe outside the body in the Cartesian system. Define this point. It have to be point of the reduction of the arbitrary system of forces. For each of the force, we put the couple of balanced forces. So it's, for example, for the force F1, we put the balanced system of forces applied in the point of the reduction of the point of the force F1 to the point 0, the point of the reduction, the coordinate reference point. We have F1 stroke and F1 two stroke to balanced forces. They balancing the system of these two forces give us 0, so we can put 0 to any point and it not impacts the equilibrium, the mechanical body and action of the assigned forces. For the force F2, we can put the couple of forces F2 stroke and F2 two strokes, the same the balanced system of forces. For the force F3, we have as well F3 stroke and F3 two strokes for any other force, and for the force Fn, we have Fn stroke and Fn two strokes. So the got convergent system of forces if have the parallel and of the same direction of the specified forces F1, the same as the direction F1 stroke, F2, the F2 stroke, but applied to another one point, F3, etc. And the opposite forces, the opposite force F1 two strokes are predetermined, determines in the couple with F1, determines the component of the vector of the rotating moment around of the mechanical body around this reference point. So this is the same for each of considered assigned forces. For F2, for example, here we have the parallel force in both the same direction, F2 stroke, and the opposite to F2 stroke, F2 two strokes, which is in the couple with F2, rotating the body. And we have for each of all others, for Fn, we have the force Fn stroke applied to the reference point 0 and the opposite Fn two strokes. That's why we have the main vector of force system and the vector sum. So if we put all forces in the one point, we have the resultant force of all applied forces if we reduce all the forces to the reference point. And we have the main moment of all forces related to this point, due to in each point to keep the equilibrium of the originally assigned forces, we have to consider in the couples as force with a stroke index and with two stroke index. They balance it, and that's why the second one determines with the specified force the rotating moment. And we have the main moment. Main moment is a vector total of the moments around the point of the reduction. Point of the reduction is the reference point is a definite one considered sample of the Cartesian coordinate system, and the rotating moments from the first assigned force, second, etc., and the nth assigned force. So we have the resulting moment as the total of all forces relative action as rotating the body around the point of reduction of the forces. And we have the resultant force applied to the same point, the point 0. And we have Poinsot theorem, the special system of forces is assigned F1, F2, etc. Fn is a vector system of forces. Acting on solid body can lead to a force equal the main vector of the force system, and to the pair of forces the vector of moment relative to the center of reduction of the assigned system of forces, which is equal to the main moment of the forces system relative to this definite one point. This Poinsot theorem follows from the originally considered theorem of parallel force transfer. We used the theorem of the parallel force transfer And we got the Poinsot theorem as a corollary to the originally considered theorem of the force parallel transfer. Questions and comments. 216.1, the reducing an arbitrary system of forces acting on solid body to a force and a pair of forces. To each of assigned forces of system, we can to any one arbitrary point in the space of the defined by the Cartesian coordinate system, we can put the couple of forces parallel by the line of action with the assigned force each, and the couple of forces the same magnitude than assigned force each of the forces, but in the opposite directions. They do not change the equilibrium of the body, because these forces put in the point of reduction, the couple of forces, are balanced system of forces. After that, we can redefine the assigned forces parallel and of the same direction as assigned one. And the assigned force itself and the opposite force applied in the point of each parallel transfer do the a couple of forces, act as a couple of forces, and this couple of forces predetermines the rotating moment of the mechanical body relative to the point of the parallel transfer, theorem of the parallel force transfer. So that is the parallel force transfer is the application of assigned force to another point in the coordinate system. It can be inside or outside the mechanical body. And a couple of forces, one of which is the assigned force, and another one is the opposite force applied to the point of each parallel transfer. So this is the result of the parallel force transfer, this theorem of the parallel force transfer. Reducing a system of forces to a point to the center of the system of forces. If we have the system of forces, we can consequently do parallel transfer to the same point of all forces, and they predetermine the resultant force. And besides of that, when transferring each of forces to the common point of the reduction of the system of forces, to do that, we put in the point of the reduction the couples for each of the assigned force. One force parallel to the assigned one, but to the point applied to the point of the reduction, and another one of the opposite direction. And this one of the opposite direction with the assigned one predetermines the summand in the determining of the rotating moment, and the parallel one of the same direction as the assigned one force for each one in the system of the assigned forces predetermines the resultant force applied to the point of reduction of system of forces. The main vector of force system is the vector of force sum. Yeah, if we do transfer all forces assigned of the system to one reference point, we can find the main vector of the force, this force system, just by use of the vector sum of the forces. The main moment, 216.5. The main moment of force system is the vector sum of the moments of all forces relative to the center of force system. And to the same point, we can determine the rotating moment of each assigned force due to when doing the parallel transfer of each force, we have to keep the balance of the mechanical body, original balance. We have to put in the reference point, transferring this assigned force each of the system. We have to put in the transferring point the balancing system of two opposite forces equal in the magnitude by the assigned one force of the system. And the opposite one of this couple put in the reference put in the reduction point of the assigned system of forces. Deposit one force to each one of the assigned system forces with the assigned force of the system. Predetermine the rotating moment. So we moving. So reducing the system of forces, we obtain as well the moment of forces. This usually is very effective to do the issues of mechanics when finding the support reactions and when finding the equilibrium conditions of the mechanical bodies under the action of forces. Because of assigned system of force of n component, we finally can have only two components. Two components, the resultant force, and another one, second component, is the rotating moment relative the point of the reduction of the system of force. Rotating moment is second component or resulting component. Points of theorem, they bring in a special system of four forces to the main vector of the force system and to the main moment. Yes, by the way of reduction system of forces to any arbitrary point, we can get two forces. Just only the resultant force and the resulting vector of moment relative to this point of reduction of system of forces. Thank you.